Hello. Okay, so we're going to have a quick look at moments and equilibrium. And so a moment is a force multiplied by a perpendicular distance. So a moment is a turning effect. So that's the first thing I'm going to write down. It tells you the size of how much something will turn. If they ask you to define it, you're going to say it's force multiplied by perpendicular distance to the pivot. Okay, oh, I'm going to sneeze, sorry, 1 second. Excuse me. Okay, it's really crucial in the exam that you write the word perpendicular, because if you don't, you're going to get not all of the marks. So please don't forget that. Perpendicular just means at right angles to, so at 90 degrees. Okay, so generally speaking, in the exam, you're going to get a plank or a rod and a pivot point. Okay, and there might be some forces acting. Okay, so in this particular case, we'll take the centre of mass of this, let's call it a ruler, and it's acting at 50 centimetres total. So if this is 0 and this is the 100 centimetre end of a metre ruler, and the pivot point is at 20 centimetres, and the weight of the ruler is 10 newtons. At its most basic, the moment that is caused by this force here is the force multiplied by the perpendicular distance to the pivot. Now the pivot is this point. Okay, the force is acting vertically, so 90 degrees to the force is in the horizontal plane. Okay, so what we always want to do is we want to make a little right angle with the force and find the distance to the pivot that's along that plane. Okay, so we're going to find this distance here. Now we're going to assume that it's a uniform ruler, so the centre of mass will act at the 50 centimetre mark, and so the distance between the pivot and the force is 30. Okay, so the force times the perpendicular distance here is going to be 10 times 30, and that's going to be 300 Newton centimetres. Okay, I can express that in Newton metres by doing 10 times 0.3 metres gives me 30 Newton metres. Okay, that's not right, is it? Gosh, sorry, terrible maths here. Been a long day of making videos. It's 3 Newton metres. Okay, and so it doesn't matter which one you quote so long as you use the right unit. Okay, so that's at its most simple. It could be that there are multiple moments acting and you have to find the total. So now we're going to look at the rod again. We're going to put the pivot at the 50 centimetre mark. Here's 0, here's 100. And so now the weight of the ruler, which we said was 10 newtons, is acting at a perpendicular distance of 0 because it's at the pivot point. Okay, so the weight itself provides no moment. So what that means is you should be able to get the ruler to balance perfectly, and both sides will be lifted off the ground because there's no net turning effect if this is the only force acting. But I could add some additional forces. Okay, so I could have a force here, let's call that 2 newtons, and I could have a force here, and let's call that 3 newtons. And let's say that this is acting at the 90 centimetre mark and this is acting at the 30 centimetre mark. A mistake that students often make is they use these numbers as the distance, and it's not. It's always the one that's at right angles to the force to the pivot. Okay, so let's just get rid of that a second, tidy that up. So the perpendicular distance to the pivot, so here's the vertical line, so it's the line through the pivot, is going to be the difference between 30 and 50. So this is 20, and this one here is 50 to 90, so that's 40. Okay, so now what I also have to consider is which way the force will make something turn. If this is my pivot point and I pull down with 2, this one is going to make it turn clockwise. If I pull down on the left hand side of the pivot, this one's going to make it turn anti-clockwise. Oh, throwing a pen, sorry. So we've got clockwise and we've got anti-clockwise. Okay, so what I can do is I can find the total resultant moment from these two, because obviously the ruler only does one thing. It doesn't do one and then the other. There's an overall impact from these. Okay, so I add them together. Generally, I take any moment that's clockwise to be positive and any that's anti-clockwise to be negative so that I can find the sum total. Okay, so I've got clockwise. I have 2 newtons times 40. Okay, so I've got 2 times 40, which is 80 Newton centimetres. Anti-clockwise, I have minus to show it's in the other direction. 20 times 3, or 3 times 20. So that's minus 60 Newton centimetres. So then to find the resultant, I just add them up. Okay, so I've now got 80 plus minus 60, which is 80 minus 60, okay, which is 20 Newton centimetres total. Okay, now what that tells me, because this is a positive number, overall this ruler is going to turn clockwise, okay, because of these two interacting. You cannot add the forces up and add the distances up. You always have to find the force times the distance of each individual one first. Okay, so now what I'm just going to point out is that you could have a force on the left that provides a clockwise turning effect. And that then is going to combine in a slightly different way. So here's the rod again, we'll put the pivot at 50, here's 0, here's 100. I could have a force here that's at 2 newtons, and I could also have a force here that's at 2 newtons, and this could be the 80 mark, and this could be the 10 mark. Let's put that at the top actually. So I know that my perpendicular distance, which is at 90 degrees to the pivot, is 40 there, and I know that this distance, which is at 90 degrees, is 30 here. Okay, but hopefully what you can see in this instance is if I pull down by 2 newtons on the right hand side of the pivot, the rod will turn this way, and if I lift up on the left, it will also turn clockwise. And so these reinforce each other rather than cancel each other out, and you get an overall clockwise turning effect. So this time you just add them up together. So you're going to have 40 times 2 plus 30 times 2. Okay, so you're going to have your 80 plus your 60, and that is going to combine together to give you a total of 140 Newton centimetres turning effect. Okay, so you can have where it acts up on the left and that will turn clockwise, and if you were to have one that is up on the right, that would provide an anti-clockwise. So let's add that in to help us out with our understanding. And let's say that this is a 2 Newton force acting at 60. So now we know that that distance to the pivot is 10, because it's 50 to 60. And so now I have to minus my 2 times 10. Okay, because that is an anti-clockwise one now. Okay, and so I'm going to minus 20. So I'm actually doing 80 plus 40 now. Gives me 120 Newton centimetres. Okay, so you can have multiple moments. It doesn't just have to be 2, you just have to add all of the ones that are clockwise and minus all of the ones that are anti-clockwise. Okay, the final thing that they could ask you is to find the value of a force or a distance if you know the object is in equilibrium. Okay, now equilibrium means not turning or not moving. Okay, so if I've got a rod and it's in equilibrium, what that means is there is no resultant force, okay, that makes it move left, right, up or down, and there's no resultant turning effect or moment. Okay, because I could have two forces that are equal in size but in opposite directions, okay, and these two in terms of the resultant force make 0, but this will still turn, hopefully you can see. So it's important that you have to say both no resultant force and no resultant moment for equilibrium. Okay, so not moving, not turning. Okay, so let us make some numbers up. Let's call this 5 newtons. Let's call this distance here 10 centimetres, and this distance here as unknown. Here is my pivot point. Okay, and I'm told that this whole thing is in equilibrium, it's not moving. Okay, so therefore I'm going to, just switch this to be down. I need to think ahead before I make these videos, really, don't I? This is 2 newtons, but it's down. So they're acting in opposite directions. Okay, so back to it. We need to work out this distance here for equilibrium. Okay, so if we have no resultant moment, then the clockwise moment has to equal the anti-clockwise moment. Okay, so I've got for clockwise 10 times 2 is equal to 5 times question mark. I'm just going to call that d for distance. Okay, so 20 is 5d, and d is 20 over 5, gives me 4 centimetres. Okay, so I would have to put this force, 5 newtons, at 4 centimetres from the pivot to make sure that this whole thing did not turn. Okay, it could be more complicated because they could actually add more than 2 forces. So there could also be a 10 newton force acting, let's make this a 1 newton force to make life a bit more simple actually. We'll call it a 1 newton force, and that is acting at 20 centimetres from the pivot. Okay, so now we actually have 2 clockwise moments. We have the 2 multiplied by the 10 plus the 1 multiplied by the 20. Okay, so the total clockwise is equal to 2 times 10 plus 1 times 20. And that now has to equal 5d. Okay, because it's still, we've only got 1 anti-clockwise, so this distance is now going to be changed. Okay, so we've got 20 plus 20 equals 5d, and now we've got 40 equals 5d. d is equal to 40 over 5, and you can hopefully see that is 8 centimetres. Okay, now what this means is we have to have moved this 5 newton force further away from the pivot to increase the total turning effect to counter the extra force that's been added. Okay, so you have to always combine clockwise equals anti-clockwise if the total object is in equilibrium and it's not moving.